Hi everyone. In today's challenge, we are going to solve this problem. The problem name is all possible full binary tree and the problem number is 894. Alright guys, so first of all, we are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java and JavaScript programming language. Fine guys, and guys, if you want to have a look on the solution which I'm going to write in this video for Python, C++, Java and JavaScript, I will share the link in the description. You can go through that particular link and you can find all the solution which I'm going to write in this video, right? Fine guys, now let's see what this problem says. So let's understand the problem statement. So problem says given an integer n, return a list of all possible full binary trees with n nodes. Each node of each tree in the answer must have a node value 0. So simple guys, we are given first of all one thing only, that is nothing but an integer value, right? So we are given one integer n, and in that with that integer, that means it is stating that we are going to have a n node. I hope it makes sense. So we are going to have a n nodes, right? So we have to construct binary trees with these nodes, with this number of nodes, right? So let's say I am creating this binary tree. So this is nothing but having a 3 node, right? So same thing, we have to construct a binary tree which will have a n node, right? And I hope you know what is binary tree. Binary tree is nothing but a tree which have a at max two, we can say at max two children, right? So this is having a two children. It can have one children as well. It can have single children as well, right? Fine. Now we don't have to construct a binary tree. We have to construct a full binary tree, right? So they have clearly mentioned we have to return a list of all possible full binary tree. So what is full binary now? Full binary is nothing but which have either zero children or full both two children, right? Which will not have a at least single children. That makes sense. Is you have this root node, so either this will have zero children, this will not have any child, or this will have both children, right? Two children. So this is called a full binary tree, right? So fine. Now we have understood the full binary tree as well. Now in each node which we are going to construct a binary tree, in each node we will have a value 0, right? So this is node, so it will have value 0. This is node which have value 0. This node which will have value 0, right? Fine, this also makes sense. Now next line, it says that each element of the answer is the root node of one possible tree. You may return the final list of trees in a node. So guys, as they have told us that we need to return the list of binary trees, full binary trees, right? So we are not going to return for, let's say I got 4 binary trees, so I'm not going to return 4 binary trees all the nodes, right? What I need to do, I just need to return the root node. So this first, let's say I'm returning this list. So this will say that this node is have itself in a binary tree, and in that binary tree, it is a root node, right? So in the second binary tree, full binary tree, this is the root node. For third binary tree, it is the root node. Fourth binary tree is the root node. So we just need to return the root of our binary trees, right? Fine, this also makes sense. A full binary tree is a binary tree which where each node has exactly 0 2 children. This is we have already seen, right? Now let's see the examples. Let's try to understand how we can do this, right? Or we can say let's understand this problem statement with example. So example 1, have n is equal to 7, right? So n is equal to 7, that means we are given allowed to make a binary with 7 nodes, right? Fine. So you can see in the we can say figure, we have a 7 figure, right? This is one figure, second, third, fourth and fifth. This will clearly help you to make us a logic part as well, right? So what they have done is nothing but they have make a full binary. You can see each node either have 0 children or 2 children, right? You can see this node either have 2 children, and but if you go to this node, then this will have 0 children, right? But there is no node exist which have only one child, right? Fine, this makes sense. So now what we can see, that with 7 nodes we are able to construct 6 node 6, we can say 5 binary, right? So one possible way is this, second possible way is this, third possible way is this, fourth possible way is this, and fifth possible way is this, right? And all these are unique. You can see guys, all these are unique. These 5 binaries are unique, but all these are full binary, right? So we are going to return all these things. In the output you can see we are giving all the nodes, but in actually we don't need to do, we just need to return the root node. This is first root node, second, third, fourth and fifth. We just need to return this, right? They are showing us like this to help us understanding the output, but we don't need to actually return whole the nodes, right? That makes sense. So the next example, n is 3. That means nothing but we have 3 nodes, right? We need to construct a full binary trees. Let's see how many possible full binary trees we can get from 3 node. So I'm going to create a first of all root node. Then I have 3 nodes I can make like this. So this is nothing but a full binary tree, right? And if I do any other way, it will not be a full binary, right? So if I, let's say this is root node, I'm saying this is right node, and after that I have taken already, now I am left with one node only, right? So if I don't write here, and if I write in the child of this, so this will not call a full binary, right? So we, for making full binaries, I have to give full value, we can say both children to this root node, either I have to give 0 children, right? So I can't give 0. If I give a 0, that means I have just used a one node. I have to use a 3 node, right? So I have to give a children, that is sure, but I can give a single, I have to give both. So if I give both, so I will now left with 0 nodes. I have used all the 3 nodes. So I can say this is the only possible full binary. So there is only one possible full binary, that is nothing but this root node. This root node, I can say this particular tree, right? So I'm going to return one only. You can see we have only one tree in this particular whole array. So this is nothing but our answer. I hope guys you understood what we had, what this problem say and what we have to do in this particular problem. So just now you need to clear with the problem statement. So problem says we are given a first integer value. We just need to return all the full possible binary, right? And we have to return just root of that particular binary. So now let's see the logic part. Let's move to the logic part and let's try to understand how we can do this, right? So in the logic part, we are going to use a simple recursion, nothing much, right? So let's understand the logic. So guys, okay, draw, go here. Fine. In the logic part, what we are going to do, guys, we are let's say for this example only 7. We have n is equal to 7, right? So what we can say from 7. And one thing, first of all, let's understand the base condition. So guys, can you make a full binary if you have an even number of nodes? Think about this. And pause the video if you are not getting. Just try to draw on a paper or anything else. Can you make a full binary if you have a number of node which is even? You will never. Why? If let's say n is equal to 2, so you will have a definitely one root node, right? Then it must have either full child, means both children, or single no children, right? So if n is equal to 2, so you will end up with like this. If n is equal to 4, so you will do definitely this, and then you will end up like this. So if your number of node is even, directly return 0. So directly return, if n is equal to, let me write here, if n is equal to 0, then you have to return empty list. And second more condition, guys, if n is equal to not 0, we can say n mod 2 is 0, right? That means nothing but n is even, right? If n is not even but it is 1, then directly we can return our this simple node, right? Root node. We don't need to go further, right? This is our two base condition, simple base condition, right? Now guys, let's see how we can solve this with n is equal to 7. Now let's move to this one. N is equal to 7, we are given n is equal to 7. This is not a first of all even, right? This is odd. So that means there is one, at least one possible full binary exit for this node, right? Fine. So what we are going to do, we are going to say there are so many possibilities. How we are going to come up with these possibilities? Let's try the recursion diagram. So guys, I'm going to say initially I have function of 7, right? Currently I have 7 node. Does that make sense, right? So what I can do, I can say fine. It is, if it is 7 nodes, so I can say fine. I can say okay, just make a one root node. So this is going to be nothing but we can say a root node. So how many nodes now left? It's left a 6 node, right? Try to understand. We are now left with 6 node. It's fine. So I can say give 1 to this or give 5 to this. So 5 plus 1 is 6, right? So 1 is this root node. Is this making a 7? Yes, it is making a 7. 5 plus 1 6 and 1 is this root node is nothing but 7. So this is one possible way. Why I'm doing a even, I can't pass even value here, even value here. If I started passing, then it will not be a full binary. So I have to pass odd value on both the sides. So 1 is there and 5 is there. And you can see 5 is also, 1 is also. And second possible way is nothing but we can say. So second possible way is nothing but you can pass 3 here and you can pass 3 here on the left and right side. So it is still a odd value, and you can see this is also going to make a full binary. And you can third possible way is nothing but you can pass 5 here on the left side and 1 on the right side. So this is still a odd and it is also going to have full binary. So if you're not getting this, so let me draw here diagram. So initially I was having a single node. So what I can do, I can say this I have a 7 node, right? So I have used one node here. I am left with 6 node. So I can say either you can pass 1 here and you can pass here we can say 5 node, right? So still they are making a 7 node, right? So we have seen that still this is full binary and there are going to be 5 nodes in this particular subtree, right? And one possible way is nothing but you can say you can pass this one node, you can pass here a 5 node, here a 1 node. So there is one possible way to get a this full binary, right? Third is nothing but which we are using pass 3 node on the both sides. So this is going to be a one, we can say 3 here, 3 here, 3 3 6 1 7. This is also going to be full possible binary. So I hope you're getting this particular part, right? Fine. Now let's go to at top again. So fine, if we are passing a 5 here, so now still this can be breakdown, right? So because this is a base condition, if 1 comes we have to directly return root. So if it is a 5 here, so what we are going to do, we are going to say still break out, and you can see in the image figure as well, if we are getting 5 on the right side, so this is nothing but a case of 5. This is nothing but a case of 5. You can see in this subtree we have a 5 nodes set. So this can also break into 2 types. You're getting this part, right? So either you can pass 1 here and 3 here, because 1 is going to use over here, right? So 3 plus 1 4 and 5, and which they have done in this first example. And then you can pass, if here is a 2 nodes, so then definitely you will come up with 1 over 1, right? That is make sure, right? Same thing goes here in this particular one. First of all, you have to figure out this one as well. So here we have passed 1 and 3, right? We can also pass 3 and 1 as well. So this is going to be recursion part, right? And this is also going to be 1 1. So there is nothing but we can say from this particular f of 5 we are getting a two possibilities. So let me just simple write here two possibilities. Same thing goes for a, it is also getting a two possibilities. I hope it makes sense. So this is nothing but I hope you're getting sense. So this particular part is giving me us a two possibilities. This particular part is also giving me two possibilities. So let me change the color. So this particular whole part is giving me two possibilities. This particular whole part is giving me two possibilities. Right. Now left with this one. So this is definitely going to be one possibilities only because f of 3 can be break down to f of 1, f of 1. This can also be break down to f of 1 and f of 1. So this is nothing but giving only one possibility. So 2 plus 1 is nothing but 5. So we are going to return nothing but answer 5. We're not going to return answer 5. We are just going to return root of this. I hope you're getting this. We have to return not number. We have to return the root of this. How we are going to calculate this? Simple guy. So f of 7, right? So this is going to have a one root. So I'm not saying this is a root node for all these things. You can see this is all gonna come up with this, I can say this one node, and let me just remove this one, this one. Now you can easily visualize this. So this is our first node, this is second node, this is third node. So we have to return this array. Does that make sense, right? I hope it makes sense. So we are just now break down our simple problem n07 into a subpart. So this is simple recursion because f of 5 is again going to act as like n07. So as earlier n was 7, so now n was 5. So we have to recursively count. So we are going to see in the implementation part how we are going to call it, but you have to understand the logic part. What actually we are doing, we're just dividing our tree into a further subparts, and we are just calculating the number of possibilities how we can get, right? At the end, we have to return just upper nodes, right? Simple thing. So let's see how we can do this with Python, C++, Java, and JavaScript, right? So guys, I am gonna first of all with I can say with the Python. So what I'm gonna do, I'm gonna say, fine, let's make a first of all a map. I'm gonna make a globally dictionary, which is nothing but this empty dictionary to just memorize our recursion part. Otherwise, it's gonna give a TLE, but definitely not gonna give in this case because let's see that constraint. You can see n is 20, right? So it may not give a TLE, but still we need to memorize it, right? So what I'm gonna do, I'm gonna say if n is equal to f, n mod 2 is equal to 0. What we are gonna do, just you have to tell me. But if n is even, number of node is even, then definitely we are not gonna get any full possible binary. So we are gonna return empty. But if n is equal to 1, then we are going to get, right? So we can say return nothing but, so instead of doing this we can say directly dictionary of if n in our dictionary. So what you have to do, you have to return simply dictionary of n. And why I'm doing this, because I have memorized it, right? So I'm going to say in 0 part you will have definitely empty, and if 1 is nothing but we can say you will have a nothing but one node, which is nothing but 3 node of 0, right? I hope it makes sense. So now once this is done, we are going to check for all the possibilities. So I'm going to say for I in range of 1 to n minus, not n, only n, and till 2, right? So I have just traversing from 1 till n with the step size of 2. And why it is so? So you have seen in the example, we can either pass 1 here, we can either pass 3 here, we can either pass 5 here, right? We cannot pass even values over here. Because if I started passing even value, definitely this will turn up with the non-full binary tree, right? So I'm going to say for I in range of 1 comma n comma 2, and here you go to left side, which is I. So I'm going to say calculate the left side, which is going to be nothing but same function. We have to use self dot all possible, and here full binary tree, and here we have to pass I, right? So calculate for this part. Now right side is going to be nothing but, let me write a right side correctly, self dot all possible and full binary tree, and here you have to call for the right side. Right side will be what? One we have already used for root node, and I we have already used for left side. So the number of node which is left from this, so n minus 1 we have already used, and I we have already used. So we have to subtract this, and you have to calculate right side for this. Now we are going to say for left node in the left side, for right node in the right side, right? So what is this? This is nothing but we can say now we got this particular part. That means we completed this recursion. So now what we are going to do, we are going to say our root node is going to be nothing but tree node with 0 value. They have clearly mentioned we have to make it with 0 value, and left is going to be this left part and right is going to be this right part. So this is nothing but simple this. So for 1 and 5 we are going to create one root node. For 3 and 3 we are going to create a one root node. For 5 and 5 we are going to create a root node, right? So see guys, these are the 3, right? But as I have told you, they are going to be nothing but we can have a multiple as well. From 5 we are getting a 2. Does that make sense, right? So from 5 we are getting a 2. So from 1 also, how many times we have to create this root node? That is nothing but we are creating over here. So from 1 we are iterating for 1 for 2 times with 5. You can see this. I'm saying the for left in left side, so left is nothing but 1 only, right? F of 1. And for right in right side, so we are going to say f of 5 is there, it's going to have a 2 child, right? So it is going to iterate like this. So from 1 to 1. So this means that we are getting two root from this side, two root from this side, and one root from this side. I hope it makes sense, right? So for this, after that, what we are going to do, we are going to say result dot append this root. So I'm going to say nothing but result, which is initially going to be this, like not here. I have to do, actually I have to do at the top. So let me do here, result is nothing but this empty. Now I've appended this in a root. Now I'm going to simply return this, but before returning I have to put the number. Okay, I have, oh don't know, it's gonna give error, right? Fine. Why it is so? Because we have just used a shortcut control plus enter. Alright, so now what I'm gonna do, I'm gonna say dictionary, self.dictionary, self.dictionary, and here I'm gonna say in this n just return, put this result, right? And here also I'm gonna say self.dictionary. I don't need to use only dictionary because this is a class method. Alright, so class variable, right. Now let's run this code and see whether we can find a node. And I have to call this function, not call, we had already written in it, right? So you can see guys, it was all the test cases. So now let's try to submit this code as well. And I hope guys you understood what we are actually doing over here, right? If you still have any kind of doubt, I know it's a little tricky one, but it's a very easy, very simple, right? If you know simple basic concept of recursion, you can easily do it, right? Alright, so now let's move to the C++. And in C++, what we are going to do, first of all, we are going to create a map, the same thing, right? Another map, and this will going to have integer, and let me take it a vector, right? Vector of what, tree node, not integer, tree node, right? And here we're gonna give a name dictionary, right? Fine. And here we're gonna say if n is equal to if n more 2 is 0, that means directly return empty. We can say like simple, right? Return empty. But if n is equal to 1, then what you have to do, you have to return simply new tree node, right? So we can say return what we can do, you can say simply return a new tree node. So new tree node, and here you can pass. Okay, so what we can pass a simple 0, right? So this is going to be nothing but new tree node. Fine. And if it is also not the case, then we are going to say let's create a one vector of tree node, and here we can say fine, this is nothing but result. Now we are going to say for each integer, for int I is equal to 1, I less than n, I plus equal to 2, you have to calculate the left side and right side. So we can say what you can say, oh, simply auto left side is going to be nothing but we can say call this function all possible full binary, and you can pass here your I, right? And same thing we have to do for right side is going to be all possible full binary. And how many nodes left now? I has already been taken and 1 is already taken for root, so we are going to say n minus 1 minus I, right? After that, once this is done, we are going to iterate over each left and right. For auto left in our left side, and for auto right in our right side. And here we're going to say fine, we are going to create a new root. So we are going to say tree node, our root is going to be nothing but new tree node 0 value, that have clearly mentioned 0. And after that, what we need to do, we need to pass a left and right. Left is going to be nothing but this left, and right is going to be nothing but this right. After that, once this is done, we are going to append our result. So result dot push back, and here we can pass our loop. I hope this makes sense, right? So we have done this so much far, and we have repeated this 2 times. So I hope now you understood what we are actually doing over here. And once this is done, then what we are going to do, we are going to say simply at the end, you have to put in your map. So we haven't checked here map as well. So I can say if our dictionary dot find this n, our dictionary dot find this n is not equal to dictionary dot n, that means nothing but it is present in our map. So we can simply say return dictionary of this n, right? And also here what we can do, we can say simply if not if, we have to simply say dictionary of n is nothing but going to be equal to a result, and we can simply return our result here as well. Now let's see whether it's working fine or not. So I believe guys it should work, right? So let's check this. You can see guys both the test case passed. So let's try to submit this code as well, and definitely it will also gonna submit it. Yeah, you can see guys it's successfully got submitted. Now let's move to the next programming language, which is nothing but Java. And I really have a fear with Java, right? So let's see how we can avoid this one. Fine. So I'm gonna say let's create a map. So I'm gonna say map, and map is gonna have an integer, and it's gonna have also list of tree node. And here we're gonna say nothing but dictionary is gonna be nothing but new hash map, right? Fine. So once this is done, we are gonna say fine if n is equal to n mod 2 is 0. So what you have to do, you have to return directly 0. If n is equal to 1, you have to directly return, you don't have to return 0, you have to return nothing but something new array list, right? So you can say new array list, right? And if it is no if it is equal to 1, so what you have to do, you have to list of new array list, and you have to pass new array list. You have to pass tree node and you have to pass 0, right? Fine. And if it is also not the case, then you have to check if dictionary dot contains key of this particular, we can say n, then you have to return dictionary dot get. And what you have to get? You have to get, right? After this, you have to create one list node, list of tree node, and you have to say fine node. We have to say simple name result, and we can see initially it is empty, right? So new array list. Fine. Once this is done, then we are going to traverse over each node. So for int I is equal to we can say 1, I less than n, I plus equal to 2. Fine. Now we are going to say calculate for the left and right side. So we are going to say let's give it a name list of tree node, and here we're going to say left side. This is going to be nothing but we can say call this function. So all possible full binary tree, and here we're going to call function for I, and same thing we are going to do here, list of tree node, and right side we're going to call all possible full binary tree, and we are going to call for n minus I 1 minus I, right? So 1 is taken already for root node, I is taken for left side, so left node is nothing but for our right node, right side. Once we go left and right side, we are going to say fine. Now let's traverse for tree node left of left side, for tree node right for right side, and here we're going to say okay, we got traversing over left and right side. So we're going to say our new root nodes, which is going to be tree node, root is going to be new tree node, and here we're going to say fine, this is going to be nothing but 0 with a left as a left node, right as a right node. Once this is done, we are going to say result dot add this root. Fine. At the end, we are going to say nothing but first of all dictionary dot we have to put this particular n, on this n we have to put this root node result, and after that we have to return result. Now let's see whether it's working fine or not. So let's check it, right? Fine. You can see both the test case pass, right? So let's try to submit this code as well, and definitely it will also want to submit it. Let's see. You can see guys, it successfully got submitted. Now let's move to the next programming language, which nothing but we can say last, JavaScript, and let's solve this with. So what we are going to do actually, first of all, we are going to define a map. So we can say map can define over here. I can say give a dictionary is going to be nothing but new map, right? Fine. Now I'm going to say if our n more to 0. So what we are going to return? We are going to return nothing but empty array. If n is equal to 1, so we are going to return nothing but we can say new tree node of 0. Right, and if it is also not the case, if dictionary dot we can say if dictionary dot has this n, then we are going to return dictionary of get n. Fine. Now we are going to simply traverse over this. First of all, we have to create an let's say const result which is initially empty. Now we are going to traverse over all the nodes. For int I is equal to 1, I less than node int. We don't use int here. We use let I is equal to 1, I less than n, I plus equal to 2, and here we're going to say const left side is going to be nothing but equal to what is going to be our left side, all possible full binary tree, and you have to call like with I, right? So this is going to be for our left side. So const right side, similarly we going to be all possible full binary tree for n minus 1 minus I, right? Once this is done, then what we are going to do, we are going to say fine, we go to our left and right side, traverse over these. So for const left of left side, and here we're going to say const right of right side, right? Now what we are going to do, we are going to say fine, we are going to create a new node. So I have to use right node, right side, right? Now we are going to say our create a new node const root, which is going to be nothing but new tree node, and here we're going to say fine 0 is going to be value, left is going to be left node, right is going to be right node. Fine. Now once this is done, then what we are going to do, we are going to say put this root in our result variable. So result dot push root. Once this is also done, then what we are going to do, we are going to come out this for loop. We are going to say result. First of all, let's put in our dictionary, or we can say map. So dictionary of set. I don't think this. I believe this is the function which we use. So let's use this dictionary dot set. On this n place we can put this result, and at then we can return result. So let's check it. I'm not sure with JavaScript, but let's check this, right? Okay, I believe it should pass. Let's see. You can see guys, it successfully passed finally. So let's try to submit this code as well. So I hope if it gets submitted, so we have implemented with all the programming, right? So you can see guys, it successfully got implemented. That means we have done the implementation with Python, C++, JavaScript, and Java. And I hope guys you understood all the implementation part. If you have any kind of doubt, you can write in the comment section. So in the short, I'm gonna just tell you that if you have any kind of doubt in the problem understanding part, in the logic part, in the implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.